Hello everyone, I am going to explain question number 2nd and question number 3rd of exercise 7.5 from class 12. So we'll start from the question number 2nd. In question 2nd, if y is equal to a sin x plus b cos x, then prove that d 2y over dx square plus y is equal to 0. So here this y equal to a sin x plus b cos x is given to us, and with the help of this we have to prove this result. So to prove this result, what thing we require? Second order derivative and then plus y is equal to 0. So y already available to us. So what is not available to us? Second order derivative of y. So first we will find out the second order derivative of y, then we will prove this result. So we will start from given, that is y is equal to this. First we will differentiate it with respect to x because y is in terms of x. So that will give you first order derivative. So dy over dx, sin x differentiation is cos x and cos x differentiation is minus sin x. Now since we want the second order derivative, that's why differentiate it again with respect to x. So you will get here second order derivative, and cos x differentiation is minus sin x and sin x differentiation is cos x. Now we got the second order derivative. So we'll start to prove the required result. So we have to prove that second order derivative plus y is equal to 0. So this is your left hand side. So we'll start from the solving left hand side. In left hand side, you just substitute the value which we obtained. Second order derivatives value we obtained is a sin x plus b cos x, and y is already given in the question. So substitute here. When you will substitute, then you will find that these are like and opposite terms. So they will cancel and you will get only 0 as the answer. That is your right hand side. So left hand side and right hand side is proved. Now we move to the third question. In third question again a function y is available to us, and with the help of this we have to prove that the second order derivative of given function y is cos x upon 1 minus x whole 1 minus sin x whole square. So its second order derivative. So conclusion is first we have to differentiate with respect to x, then again we have to differentiate it to get the second order derivative. So we will start the question. First we will write the given function, that is y is equal to sec x plus tan x. To get the second order derivative, first we have to differentiate it with respect to x. That will give you the first order derivative. So dy over dx, sec x differentiation is sec x tan x and tan x differentiation is sec square x. These are the standard formula. So learn it and write down the differentiation directly. Now since whatever result you have to prove, in that you can observe that we have only the trigonometric ratios in terms of sin and cos, and here when we differentiated we obtain it in the form of sec and tan. So conclusion is here only just convert them in sin and cos. So when we convert by using the reciprocal of sec x is 1 upon cos x and tan x is sin x upon cos x, again reciprocal of sec x is 1 upon cos square x. Take the LCM. After taking LCM, you will obtain here cos square x. So cos square x from 10th class identity, that is sin square x plus cos square x 1. From that cos square x you can replace by 1 minus sin square x. Use here a square minus b square formula, that is a minus b, a plus b. By that you will see that these two brackets are like, so they will cancel each other. We are remain with only this bracket. So since we know that we have to find out the second order derivative, so this fraction you just shift in the numerator so that we can avoid the fraction differentiation problem. Now it came in the form of x to the power n, so we can differentiate it in more better way. Now again we will differentiate it with respect to x because in the question we have to find out the second order derivative. So here onwards students, you have two choice: either differentiate it by assuming it as numerator upon denominator by fraction formula, or convert it in the form of x to the power n, and then as I prove you can. So you can do by both way, whatever you want. So just see this process. Here I converted in the form of x to the power n because it is in denominator, power is 1. So when we shift in numerator, power get minus 1. So x to the power n differentiation is n, that is minus 1, x n minus 1. That's why minus 1 minus 1. It is the formula n x n minus 1. And because of the chain rule we have to differentiate this function again. Now here minus 1 is minus 2, and when we differentiate it 1 differentiation, you know it's constant, so it's going to be 0, and sin x differentiation is cos x. Now just see here, this bracket's power is negative 2, that is minus 2, so it will come down by become positive 2, that is 1 minus sin x whole square, and this minus cos x and minus 1 will multiply, that will give you positive cos x, and that is your required result. Hence question number second and third is completed. So students, these two questions are not so tough. Functions are available to you, and with the help of given function, required result you have to prove. So if they are asking for the second order derivative, so first find out the second order derivative, and in required result substitute, that will give you your solution. Thank you.